Hey everybody, Ben Bosley here with the Meter Guys, and have you ever thought about how sensitive you are? Of course not. But at any rate, have you ever thought about how sensitive your 4-gas meter is? So for this meter minute, we're doing cross sensitivities. All right, cross sensitivities. So here we go. So we have to define it a little bit, and then I'm going to talk about some cross sensitivities that most of us will see because we have a basic 4-gas meter that includes a CO sensor and a H2S sensor. So we'll kind of primarily focus on those things. So first off, what is a cross sensitivity? Cross sensitivity is when a gas or a vapor makes it through the filter and causes a chemical reaction within that filter. So the neat thing to know is it can be a positive reaction or it can be a negative reaction. One of the reactions that we see the most in the field is on our CO sensor, we'll see a positive reaction. One of those that we'll see is acetylene. Our CO sensor will see acetylene 1-to-1 up to about 500 parts per million. Why 500 parts per million? Because most of our CO sensors don't go higher than that. So you'll see 499 and it'll kind of block out. So that is a cross sensitivity because that gas is able to make it through the filter and react in that chemical causing a reaction. So one of the negative ones we'll see is chlorine. If you see a negative reaction where your CO sensor goes into a negative, you might have a chlorine spill, so you can see a negative reaction. That is also a cross sensitivity. So I've thrown up a couple of the charts here as we're talking, and you can see different meters and different makes. So again, the technology that you guys are using, whether it's MSA, whether it's IS, whether it's Draeger, they all have their own cross sensitivities because different manufacturers use a different substrate in their chemical process on their sensors for you to be able to figure out what that cross sensitivity is. So you need to know what that chart actually is doing for you so you can apply it on your calls. Last couple things I want to talk about real quick is hydrogen and your CO sensor. Understand that your CO sensor sees hydrogen very well unless it's filtered out. Most manufacturers do not recommend that you use your CO sensor for a hydrogen leak, but understand that our CO sensors see hydrogen very well unless they're filtered out. So again, whether it's batteries, hydrogen leak, if you've got a peak on your CO sensor and there's no source of CO, think hydrogen in the back of your mind also. The other thing I wanted to talk about was CO2. So carbon dioxide, though it's not an EChem problem, it's a catalytic bead problem. So when we talk about catalytic bead and LEL sensor, there's a reference bead and then there's a catalytic bead, right? So we have a standard and then we have the experiment side. CO2 is a cold gas. It will make that reference bead drop down, therefore seeing the catalytic bead, seeing that it is a flammable, right? So there's a temperature change between the two. So you will get a false positive and you will chase a LEL when there's no LEL, it's a CO2. So that is what we would call cross sensitivity. At the end of the day, there is a lot of technology out there. There's a lot of understanding that we just aren't good at. So reach out to the Meter Guys. This is what we do, making sure our responders are safe. At the end of the day, like we say, you need to know your meter, know your technology, and know your cross sensitivities. That's your Meter Minute.